So tonight's topic is project management. I believe this is chapter 3 or chapter 4 of your textbook. So the focus of tonight's session will be the use of a tool that is used in management, in project management, mainly as a way to monitor and control progression of projects. Namely, the tool that we're going to talk about are, and some of this you're already familiar with, probably you've seen this already in some of your classes, known as the Gantt chart, which is a way to represent a progress of project in terms of activities that are needed in the completion of a project. So we will expand this and we'll talk about a couple of important tools, and they are the critical path method of PERT CPM, PERT CPM. PERT is a project evaluation and review technique, and then the CPM is the critical path method. So and then we'll look at some examples in terms of the application of PERT CPM when you try to represent a project in terms of a network diagram. So for this particular file, I think there are a couple of topics here. The other topic that you will see if we scroll down is on learning curves. I used to cover these two topics in one session, but that's kind of a little much to cover. So I've split these two topics. The learning curves, we will cover this in the 5th or the 6th week of the term. So again, because I've just broken these two topics into two sessions, they're kind of shorter sessions and much easier to digest. So let's talk about project management. This is something that we will define a project as a series of related jobs, usually directed towards some output, a major output, and requiring a significant period of time to perform. Projects are considered to be sort of, one-time set of tasks to accomplish. Yes.
Renee, what's your opinion on the PMP certificate? Project management professional.
Depends on your job if it's required.
Okay.
I don't have a PMP certification, so
Say it again.
I found it quite dated.
Dated.
I did it, and
Okay.
I feel like it's me.
was it easy?
No, it was hard. It
Uh-huh.
was like based on really old information. And
Yeah, I know the DoD or DOW now, they
Required.
highly they put that equal to a master's degree.
Oh, really?
Yeah.
Yeah. Do you have to take like lessons or
Educational hour.
Yeah, the PMP, you have to have like a certain number of years in management to be able to sit for the test and then pass the test, and then I think there's CEs that you do every 3 years or something to stay.
So it's a rigorous, process training.
Yeah, I'd say it's more like the testing route rather than the education route. I mean, you have to be educated to
Well, it tests your knowledge and skill.
I was just curious if you felt that combining the MBA with the PMP would stack, or you think that's not necessary in itself.
Oh, I think it would. Again, it depends on if your job requires you to manage projects. Yeah, I think that would be a good. Rather than your cap, something that certification like that would be useful. Okay. So tonight, here are the things that we will try to accomplish. And as I mentioned, our focus will be mainly on the tools that are used in project management in the area of monitoring as well as controlling projects. When you say control projects, we try to control scarce resources, human resource, machines, tools, time in particular, and budget, right? So One of the ways that we can evaluate whether a project is going as planned per schedule is by way of evaluating the PERT CPM. So, well, in relation to PERT CPM, we will learn how to create a network diagram. So the question is, what is a network diagram? A network diagram is basically just a bunch of nodes and arrows that in this simple network diagram, you have the following characteristics. You have activities. If you're working on a project, for example, when you did your MBA 519, the practical research, you did a survey. There is a series of steps that you have to do in order for you to have your final report, which is I don't know, some of you did, I think, who did the AI projects? I haven't seen the report, so how did it go for you guys?
Michelle did it too. I think the most challenging thing were the delays that we couldn't control when our survey went out. And
Right.
so we ended up with a very, very short period of time that
Uh-huh.
our survey was out, and that definitely negatively impacted our total number of surveys that we could clean and analyze.
Sure. And unfortunately for this kind of project, you just constrained to complete your project within like an 11-week period.
Yeah.
So, you have to be mindful in terms of when you estimate the time to write your proposal, for example. And then after you write your proposal, part of the proposal process is you write your survey instrument. And then, when you do your survey instrument, you have to go through the review process. You have to submit your survey to a review board and to make sure that we're following the, especially when you're dealing with human subjects, that make sure that we're not creating any issues related to your human subjects. But most of the surveys that we do in the academic world, or at least in the surveys that we do, they're really exempt from that kind of review process. Yes, Brian?
Well, this is also heavily implemented in the MDO program, as
Mhm.
to how we have to develop various projects
Sure.
to create proofs
Uh-huh.
and to create gradual edits, but you also run through multiple scenarios
Sure.
to be able to get to a definitive thing. And at least with my experience with product design, this is something I have to consider pretty frequently.
Sure, yep. And the university is going through this process of, the Workday, replacing our banner system with Workday, and it's been going on for like, I don't know, 3 years now, I think. Is that right, Mary Katie?
3 or 4 years.
3 or 4 years, and how we're talking about expense when you have project overruns. So anyway, the characteristics of a network diagram, you'll have the activities, that major activities that you identify to complete a project. And then it is important that you're able to determine the precedence of activities. What goes first before you can, start another activity. Okay, so that's here identifying the immediate predecessor. Or sometimes network diagram will say, instead of immediate predecessor, will say what comes after. But the way that you interpret this, convert this into a network diagram. Okay, so if you're looking at this network diagram, it tells you the sequence of activities that need to be performed. Okay, so here it says you have to complete a activity, whatever that might be. Maybe in research, that might be the identifying the problem, research problem, before you can write your proposal, right? And then after you write your proposal, maybe implement it, and so on and so forth. So here it says that A needs to be completed before you can start B, and B needs to be completed before you can start C. And once you have C, you can start either D or E, either at the same time, or sometimes you don't have to start them at the same time, especially if one of the activities has a slack. Yes.
Is this, would you call this a roadmap?
Kind of, yeah, I mean, in a sense it is. But I think the roadmap is, you know, doesn't tell sort of the precedence relationship. Because you can probably go anywhere, whereas this, it tells you things you can do before, you have to do, things you have to complete before you can move on. So in this example here, I said that you can start D and E either at the same time, or sometimes you may have to delay starting an activity, especially if there is a slack, right? So in this case, it's just kind of looking at this diagram, you know that E will take 5 time units. D will take only 2 time units, which means that you can delay D for as many as 3 time units without delaying the project, okay? So from when we look at the, you know, determining critical path and critical activity, we would define critical activity as one that you cannot afford to delay, because by delaying that project will have an impact on the completion time of the succeeding activities. Yes.
So with D and E in
Uh-huh.
this diagram, they're both critical.
They're not both critical, only E is critical.
Okay.
And because you have to complete E in 5 time units.
But you also have to complete D. What are
Yeah,
those alternative paths?
correct. So if you start D as at the same time as E, then D will be completed like 3 days ahead of E. But you cannot start F before you can, before D and E are completed.
Both are completed.
Correct, correct.
Thank you.
So if you delay D by 3 time units, that means that D becomes critical. So yes,
Renee, just from like a project manager perspective, you're not necessarily a subject matter expert on these critical milestones along the way. So how do you create this network first approach when you may not know how many time units it's gonna take or what's gonna be needed
Well,
for resources?
that's part of a project manager, you'll have people that will help you develop these, or people who understand the project activities.
So I'm just curious, like, how do you get a good estimation of that time block?
It's as good as, maybe looking at historical or some work that you've done in the past. So we'll talk about the 2 kinds of time. There's the deterministic time, and then there's the probabilistic time. So most projects are actually in the probabilistic mode, where you say, I can complete this activity in a minimum time of say 5 days, maximum time of 7. So there's a range there, and most likely say 6. All right, so we will rely on our understanding of probability distribution, basic normal distribution, where you can compute what is known as probabilistic time estimates. Okay, so here's an example. Let's say that this is a new project and you have identified the activities, but you really don't know exactly how long it will take to complete each one. You can simply say an estimate based on your understanding of the project and based on perhaps experience. Say, hey, optimistically, we can complete this in 3 days, 3 weeks, 3 months, whatever. And most likely, if things what can go wrong goes wrong, it'll be completed in 15 weeks, but most likely 5. So there is a way that we can manage probabilistic time estimates. That is, probably what's happening out there more than something like this, where the time is given exactly as 2, 1, 1, 2. So this one is known as a deterministic time estimate. Okay? And this is much easier to deal with, at least in terms of identifying the critical path. Whereas for the probabilistic time estimates, we will use the normal probability distribution in determining the likelihood of completing a project within a given time period. Okay, so we'll have an example of that application. Okay, so the arrows here represent simply directional relationships between activities, right? So it says here that C is needed to complete before you can complete D, or you can start D, and before you can start E. And then D and E are needed to complete or to start F, and then F is needed to complete G. So in this simple diagram, we will identify the different paths from beginning to end. And it's a very simple diagram, so we can see right away here that there are two distinct paths, right? And these paths are A, B, C, D, and then E. And then if we add at that time units, whoops, A, B, C, D, sorry, not E, A, B, C, D, F, G. Okay, so that's one path. And the next path is A, B, C, E, and then F and G. So just add up all the time units that are found in these activities. So that's 2, 4, 6, 11, 12. Is it my arithmetic correct? And then 2, 4, 9, 14, 15. Right? Am I correct? My addition? So in these two paths, when we talk about critical path method, the critical path is the one that shows the longest completion time. It's kind of counterintuitive. You say, hey, the critical path is 12. Not really. Yes.
What about price?
What about what?
Price or cost,
For,
the critical path.
well, no, it's not, you have, when you have these activities, you already have those, the resources priced out. So really, here we're only talking about time, not necessarily cost. The
Right.
cost will come when, at any point during the completion of the critical activities. Okay, what are the critical activities? Critical activities are those that are contained in the critical path. Okay, so A, B, C, E, F, and G are what we call as critical activities, meaning from a manager's standpoint, when you are, your time is scarce, right? Again, we talk about the 80-20 rule. You spend 80% of your time on 20%, right? So in this case, you'll probably spend most of your time monitoring the of these activities. Yes.
So your little chart in the middle, doesn't it say that
Is the middle here?
item F has, it requires both D and E on it, so wouldn't they both be in the critical path?
Not necessarily, because D has a slack of 3 periods. So that means that you can delay D up to 3 days.
You can't not do D, so why
You
would,
cannot, well,
so why would D not be in the critical path?
D, did I miss that one?
Cause D.
You were saying you
Oh,
could.
D, no. D is not a critical activity because you can't, there is a slack time there of 3 time units.
Versus E.
Well, the
Okay, you're okay, is that,
So the critical.
does it make sense? Rose?
I'm trying to, this is me seeing if I understand as well. Said another way, you could start E before D.
No, you have to start E before D.
Okay.
You have to.
So then, I guess I also don't understand why D is not critical.
Yeah, because here, once you're done with C, that means that if you have to complete the project in 15 time units, that's your critical, that's your target completion time.
Okay.
If you delay E, if you don't start E right away,
Oh, because you can start D and E at the same time.
you can, but you don't have to start D.
I got it. So it makes it critical because if you started D, but you didn't start E, you're not getting done on time.
No,
Because if you start
Yeah.
E
So
later,
that's
then,
why D is not critical because you could start E before D and still make your time.
correct,
I
correct.
see.
So if you delay E by one time unit, this becomes 6.
Got it.
That
I
is
see.
now, so in terms of the cost, anytime you delay completion of a critical activity, and if you still want to maintain that target, what does that mean? What would you have to do to activity F or G?
Speed them up.
What?
Do them faster.
You have to not infuse more resources so that you can.
Somehow make it
Quicker.
go quicker at the end.
Right, right. So that's where the cost comes into play. That if you're still wanting to complete it in 15 time units, if you delay it by one time unit, that means you have to make it up either an F or G, depending on what is the cost associated with each. I think the book talks about that you have to look at the cost, whichever is least has a lesser cost per time unit. You crash. That's the term there. Crashing. Crashing means shortening the completion time of a critical activity. You do not crash non-critical activities because it's a waste of time. Yes, or money.
So this happens when in the entertainment industry, we schedule it out based upon a best estimate of how long it's gonna take to like shoot a bunch of scenes in one day.
Uh-huh.
But network television shows are notorious for going into what's called golden time, which basically means every hour we're so into overtime that everyone on set gets paid their entire day rate during that hour, but they will do that and they will spend that money because this show has to then go on the air.
That's a
on a
specific
set
time,
And
correct.
so they have to have all of the shots in the can so
Right.
that it can go into editing and music licensing and
That's
all of
right.
the other stuff that has to go. So it's ridiculous how much money is spent, but they do exactly that and they'll squish the last scenes of the day, right, to make their day.
Which
And they'll
is
spend tons of money on it. It's ridiculous.
expensive, right? Yep. Okay, so are we clear here in terms of, what the critical path is and does this distinguish from a non-critical path? Yes.
so I guess kind of Rose's example is when you're thinking about integrating Slack into your design, is that kind of the purpose of Slack is to create a
Not
flow cushion?
necessarily. No, you don't want to, in fact, you don't want to introduce Slack unless it's necessary.
Because that's also expensive, right?
It is.
So if the network television show planned an extra week into the budget for this show, that actually would probably be more expensive than 2 hours of golden time on a single day. I'd have to run the numbers. They're
Yeah.
gonna say that it is because that entire week has so much else involved. Like
So-
also, for example, it would cost a lot to like cut the day on time and then try to make another day as well, would also not work.
There are certain things and activities that are deterministic. This particular activity will take 2 weeks exactly, But there are maybe in your world, Rose, in the film industry, maybe you're talking more about some of them or most of them are, the probabilistic.
They are 100% all the time.
Yeah.
You're guessing.
Right. Okay, so, there's a way to evaluate this kind of projects that have probabilistic time estimates, because once you're able to determine the probability that project will be completed in say 90% probability that a project will be completed, you can use that probability to estimate the cost associated with delays. We use what we call as expected costs. Expected cost is when you apply a probability to the cost associated with a delay.
And they
Okay.
build that in even to some of these budgets, that at least a few days will go.
Right, right. I mean, just like, when you're doing budgeting in terms of your household budgeting, you always have maybe a miscellaneous line item there. Because your expenses from month to month, maybe you say you have an average expense, but sometimes it's more than what you budgeted for, or sometimes less. But you want to protect yourself from times when you exceed your budget. Okay, so going back here, are we clear here? Alright, so it's kind of relatively simple or easy to determine. So this is what we call a slack. 3 days for activity D. So when you have a slack like this, that means that again, for planning purposes, you know that you have resources associated with this. Resources such as machines, manpower. That means that you can free up those resources. You can divert them elsewhere. Okay? All right. Yes.
Sorry, one more question about
Sure.
the Slack thing.
Uh-huh.
So would there be Slack in between A and B and B and C? Like if you submitted something and you knew it, you needed 2 days to review it or whatever? Or am I misunderstanding?
No, there's no slack here. When you have a critical activity, you have zero slack, meaning you have to complete that activity in 2 days.
Okay, but when you're
Yeah.
mapping out your project schedule, if you know that there's gonna be a gap in between two of the things,
Like this.
well, not necessarily two different things that need to happen concurrently, but let's say step A is you submit application for a permit, and B is you implement your permit.
Correct. Right.
That waiting period in between A and B, is that Slack or is that?
Oh, no, it's because you're waiting. So A,
Make your task.
you know that your estimate, it'll take 2 weeks. So the waiting period, quote unquote, for B is already embedded in here.
Okay,
Because you cannot start B until you've heard from the bidder, right? So that you've already included that.
okay, that makes
estimate
sense. Thank you.
Okay. So let me go back here. Gantt chart are commonly used also as a way to monitor activities, but there is one disadvantage of using Gantt chart compared to a network diagram like this in terms of figuring out which activities are critical, which aren't, okay? Because if you look at the Gantt chart like this, it really does not tell you the sequence or the precedence of completing the activities. Gantt chart will simply tell you the completion time of an activity or the project, but it doesn't tell you which of these activities are critical. Right? Therefore, it is not easy to determine from a project manager standpoint, which of these activities to focus your attention to. Okay, so going back here, we've already kind of essentially talked about these in that small example. In network planning models, the critical path method, that we have a sequence of activities that form a network. Okay, we saw that here. These are activities that form a network. Then, the path taking the longest time, as we observed there, 15, is called the critical path. And the critical path method allows us to identify activities that are essential in the completion time, the timely completion of projects. So what are the prerequisites for the critical path method? When you are looking at a project, you have to define jobs or tasks that are important in completing a project. Okay, there is a begin and an end. The end period is when all of the jobs that we have identified are done or completed. Second, the jobs are independent. Okay, meaning they don't rely, they're not relying on other jobs. And then tasks will follow a given sequence. Okay. So what are the types of critical path methods? Already mentioned this earlier. One is you have a critical time estimate, the deterministic time. You know exactly how long it will take to complete an activity. There's no range. You say it'll complete it in 1 day, 1 week, 1 month. Then we have the critical path method with time estimates, a probabilistic time. Right? And time cost models. This is not, we will not really go into this, but this is used when trade-off information is a major consideration in planning. So that is looking at, I think an example I did earlier is that if you're going to crash a certain activity, you have to look at which activities can be crashed based on the least cost approach. So this is used to determine the least cost and reducing total project time. Okay, so steps in this CPM with single time estimate, activity and time identification. So it's important for us to do this activity and time to have, and then activity sequencing, knowing what activities need to be accomplished first before you can move on to other activities. And then number 3 is determining the critical path. And before we can determine the critical path, this is where you convert these two into a network diagram. Okay. And when it comes to converting activities like this into a network diagram, there are 2 conventions that are used. One is known as activity on arrow, or AOA. And the other convention is activity on node. Okay. AON. Now, which of these 2 do you think is this? AON. Which one? AON. Yep, AON. Activity on node. If you were to represent this in activity on arrow, you'd say start. Oops. Activity A. Node 1. So the nodes will simply be identified by numbers. And then activity B. And then you have node 2, and so on and so forth. Okay? Either one will allow you to identify the paths. I prefer to use the activity on node because when you are doing activity on arrow, sometimes you'll have to use what is known as a dummy, activity, which is something like this. For example, let's say that is a prerequisite for no. I have to think about an example where you have to use a dummy activity. So a dummy activity is one that really does not contain any time. The arrow simply represents. Oh no. I combined a couple of things in my example. I should have used something like that. Meaning A is a an activity that precedes C.
Yeah.
A is also an activity that precedes B. But since you cannot have two arrows coming from one node, meaning like this, you cannot have two here, this is C, or this is B, and then C like that, that's not allowed. So we'll have to create a broken arrow here that simply says, hey, A needs to be completed before whatever this activity, say that's B. So that's why I prefer the activity on node, because it's much easier to use. Okay, now let's go back here, because I haven't really explained how this network diagram was created using this simple activity table here. Let me see if I can.
What is the middle one?
Which middle one? This one?
Yeah, what is that?
Oh, it just simply says the sequence, which
So
one
it's
precedes
I mean, what is it, stand for immediate
immediate predecessor.
predecessor?
Uh-huh.
Okay, I missed that, thank you.
Right, yeah. So what this says that what is the immediate predecessor of A? None. So that's where you say. Immediate predecessor for B, A. So that's why you create that. And maybe I'll start from scratch here. Okay, so let's start here. And we build our network diagram. Oops, deleted. Okay. So we start with A. For A, there's no president, so we start with A. And then, so scratch that. And you can write 2 there if you want. And then B says immediate predecessor for of B is A. And then you say 1. A predecessor of C. I mean, predecessor for, let's see, AB, done, C. Okay, done. And D, predecessor is C. Okay. E, predecessor is C. Okay, and then F, the predecessors are D and E. And then G comes after. Okay. So a little bit different from the original, but it still preserves the sequence of activities. Right? So, for your assignment, it would be easy, probably best to just write it out first like this, and then you can just copy these, copy and paste them, so you don't have to recreate the circles and arrows. You know what I mean? Copy and paste.
Is it okay to do bars, or do we have to do the rule
The
circle?
bars is involved.
Like the bars that show like the length of one, or like.
Oh, but so you extend it, it's really not necessary because you probably run out of room if you did that. So, the time units here are should tell you sort of the length of time. Okay? Are we clear there? So, this is when you have a deterministic deterministic time estimates. Now, in this next slide, this one is a technique where we try to identify what is known as the early start, early finish, meaning these numbers that you see here represent an early start for an activity. So you start with time 0, okay? That's what that is. The early start plus the duration of that activity gives you its early finish. Okay? The early finish of this activity becomes the early start of the next activity. So 2 plus 1, that would be the early finish of activity B. that becomes the early start of activity C. And then plus one, that's the early finish of activity C. Right, you get it? The numbers at the bottom in yellow are what we call as late finish and late starts. Late finish and late start. So how do we develop these numbers here? Okay, I think I'm going to show this in a presentation mode. Okay. So in identifying the early start, early finish, late start, late finish of the activity. So you have four numbers there. Early start, early finish, late start, late finish. Right? We use this. It says the forward pass. The forward pass means start from time 0 all the way to time 15. Okay, why did I say time 15? Because it takes 15. Right. Okay, so that's the early finish. Right? So the early finish is early start plus the time completion of an activity. I kind of explained earlier, right? So we start with activity A. It starts time 0, beginning of the project, plus 2, so that's what this is. Okay, and that early finish becomes the early start of the next activity, plus 1, 3. This becomes 3 here, plus 1, 4. And then it branches out. The early start for D, what do you think the early start will be? 4. 4, okay. And that also happens to be the early start for activity E. For activity D, the early finish, meaning if you started it right away, the 4th time period, then your early finish would be 6. Okay? And then this, 9. Now, we have 2 arrows leading into activity F. You have 2 numbers,
9,
which are what?
9,
Why?
because E has to be done before it.
Yeah.
And you can't start at 6 because E's not done yet.
Correct. So in the forward pass, when you have multiple arrows leading into an activity, you use the largest early finish. So that would be 9 here. Okay. And 9 plus 5, 14. 14 plus 1, 15. Okay, so that's the early finish.
Should I have this for?
I hope I'm on recorded mode.
Looks like you are.
You set that up.
You should get a red thing here.
Oh, I think I see a red dot.
Yeah, it's
So what?
recording.
Okay, thank you. So that's the forward pass. The backward pass says, what is the late finish? And if you want to complete your project on time, your early finish must be 15. Makes sense, right? So for the backward pass, you have late finish minus T to complete the early or the late start, late start. Okay, late start here becomes the late start becomes the late finish. Minus 5, 9. And then 9, 4. So that one would be 9 because there's only, and then 9 minus 2, 7. If you look at the difference between, we said that activities A, B, C, E, F, and G are critical activities. If you look at the difference between the late finish and early finish, it's 0, right? 0 here, 0, 0, 0, 0. Listen,
Just the resource allocation just doesn't make sense for me on this because if you have 2 extra days with resources, why couldn't you get E done faster? Or,
Well, it's already, in the planning, it's already sort of maybe perhaps already imputed that the resources are used here.
right, say a product needs to cure, or something needs to, paint needs to dry, whatever, it takes 5 days, whatever, so. You can't start F without the paint drying,
Correct, so maybe that's the paint is drying
so
over
it's
here.
literally you're just stopped.
Correct, yeah, so that one, what this might be, I don't know what that might could be in terms of the painting.
It's not a good analogy, but it
Yeah.
serves it, yeah.
But you see here that, this is simply says that whatever this activity is, which is a prerequisite to F, if it only takes 2 days. Don't extend it to 5. Right?
I'm just thinking in my experience when I'm working with teams and members of teams, people will get done at different times. And you don't want that resource sitting around, right? So if you can allocate it to the people that were on D over to E and expedite that process,
Yeah, if you
so-
can, but I think that's already sort of maybe in your planning, that goes, maybe it's already included there, or what? There's nothing that says that you cannot use those resources elsewhere in some other.
Yeah.
Right,
A different project.
yeah,
Yeah.
because we just sometimes we pull people from one project and move them elsewhere because maybe they're not
If you know you
needed.
have Slack there with specific craftspeople, let's say making a product, and you know you have Slack there, you can schedule it so that those people can go work on something
Something
else
else,
and potentially take Slack out of something else. because-
Really, no.
Oh, sure, this is a best.
So-
Really specialized people. You can't be like, okay, go wireless people go.
That's why you have to cross train your people so that they can hear a sign.
Now you sound like my boss.
Well, no, but that happens,
Let's say you have multiple departments. D is department D, E is department E. D can only do D's job, and D's manager is handling all of their stuff. They're gonna make them available for 2 days. E is gonna make it available for 5 days. E can do whatever they want, but you can't do F until D or E do their thing.
Correct.
D can't help E and E can't help D. They're two.
That's kind of I mean, if you're able to allocate those in the planning, that should already be part of,
Right.
say, hey, I'm going to allocate the resources here
Well, this
to
is part
E.
of kind of what.
That's why I'm already, I'm
Like,
going to assign you to 5.
Each department's availability, their capacity, whether or not they can be available for
Mhm.
the project.
Yeah.
Yeah.
It's already part of your planning here.
Right.
Yeah.
Okay, so are we clear in terms of the backward pass? And I was saying earlier that when you're looking at critical activities, they will not have, this will be 0. The difference between the early finish and early start and late start. Whereas the non-critical activity, if you look at the difference between 4 and 7, which is 3, that's the slack.
That's exactly what I was gonna ask. So the early start and the late start just is showing us in picture form where the Slack is. Okay.
Correct.
Great.
Alright. So to complete, you'll have that and oops. Okay,
Looks like you have a question in your chat.
who is raising? Somebody from Zoom?
Just a chat. There's just.
Oh, it's a chat.
You're welcome.
It was earlier, I think we addressed that.
Now, Slack in this case, though, means that D can be done in the time that E is having.
Yeah, so you can delay, meaning you can delay D for.
E has Slack. The right.
Yeah,
Okay.
you can delay for as many as 3 days. No more.
Non-critical.
Yes.
Well, in the example, E is training. And D is coming up with like a strategic vision or goal of like what your service should look like. So in this particular example, I would say it should start at the beginning. So the
This one?
management,
But it doesn't really, have an impact, even if you start D at the beginning. Will not have an impact on D nor on F. Got
It says develop service vision and goals, which I think if you're training your staff, you should have clarity on your vision and goals, you know?
Yeah, I'm sure you do, but this one is,
I think that's.
I don't know how,
Like prior to
that
the experience.
is applied here.
These are working in concert independently, basically.
Right, remember one of the activities are independent.
Right.
One of the assumptions, yes.
So meaning that from each node, there's already stipulations and information given, so the dependent, then it's a priori to, so prior to the experience of. This is already defined, if that's not a critical component, then you're just.
There's one,
Yeah, meaning that if one path is non-critical as to time completion, then you're focusing on what's more pertinent.
but then the more, when you say more pertinent, you really should be focusing on A, B, C, E, F, and G. Okay, so that's the developing, identifying slacks among the of the different activities.
This launch.
Now, in this next example, this is now where we deal with activity time, completion time as variable. Right, again, most projects are like that. You can simply say, on average, we can complete it in X amount of time, but there's a possibility that it will be shorter than the average or longer than the average. So that's where you have this optimistic, most likely, and pessimistic time. So the process of developing time estimates here, we start again with developing a network diagram, right? So let's do that on this slide here. Help me out. We'll start with what activity?
A.
A. So
Uh-oh.
we'll do activity on node, right? A. How about B?
It doesn't have any predecessor, so you're starting A, B at the same time?
Correct. One not necessarily at the same time. Depends on, if A is critical or not, right? You can start it at the same time. One of them will have a slack, especially one that is shorter.
So
right?
A is more critical because it's higher, it's more time units and likely, and pessimistic is 15/14, so.
Yeah, by looking at these numbers. Okay, so how about C?
Comes out, right?
Comes after A. Okay, how about D?
Also after
A,
After
Nope.
A.
oops. Comes out of A. Where's my eraser? So this is where I found, if you were drawing this, you'll be erasing a lot. So let's say if we go this way. How about E?
C.
Alright. F,
D,
G,
B,
H,
E, F together.
and
He has to lead into it as well.
G
No,
and
sorry, I.
H.
Yeah.
Okay. So we've drawn the diagram. Now, how many paths are there? Unique paths from beginning to end. Here's the beginning. And here's the end. Three. How many distinct paths do you see?
2.
I see three. Three, okay. What are they? A, C,
E.
E,
H. I.
okay.
A.
Next,
A. D. F. H. I.
A, G,
F.
F, H, and I. And then the last one is B,
E. G. G. I.
G, and I. So when you have determinate or probabilistic time, we will compute average completion time of an activity as well as variance or standard deviation, right? And in this case, there's a simple formula that we use in terms of computing average completion time. Let's just say C, the expected completion time, T sub E, of an activity is computed as optimistic plus 4 times most likely plus pessimistic divided by 6. So if you're looking at that formula, it's actually a weighted average. Okay, what are the weights for the time estimate? So for the optimistic, you're giving it 1/6
Yeah.
time. The most likely, giving it 4/6 or 2/3. But pessimistic, same thing, 1/6. The sum of this is equal to 1. So if you graph these probabilities, here's O, M, P. Here's the probability. 1/6, 1/6, 4/6. So that kind of resembles a rough normal distribution. So this tells us that we can use the standard normal distribution as an approximation, where we will also compute the variance. The variance is sigma squared E is, what is it now? Pessimistic minus optimistic divided by 6 squared, I think. Let me double check. Been a while since I used this formula. Let me remove this writing.
Is that a number 4 before the end formula?
Yeah, Oh. That's weird. The writing was not on the slide, but it was on the screen. That's right. Just delete all these. That's there.
I think they just like I say with the goal.
No, I control Z.
Yeah, undo.
Yeah. But I have a lot of individual notations there, so it'll take probably just as long to erase these numbers there.
I have like a drawing program on here.
There should be, like I was using that part there, and then
But you might have to deal with last slide if you're.
yeah, I'm still kind of figuring things out here. So. Okay, so this slide gives us the completion, the average time. This is what I wrote earlier, O plus 4M plus E divided by 6. So if you do the math here, the average completion time of A is, 7 time units. And then B, 5.33. And then H, 4.0. So that's how these numbers were computed. If you were doing this by hand, by the way, you will not be doing this by hand because the template will compute them for you. I'm just explaining how they are computed. Okay, so when you look at the template, you know exactly what those numbers represent. So those are the average completion times of each activity. So I was right. The variance is the difference between the pessimistic and optimistic squared divided by 36, or when I wrote earlier, P minus O divided by 6, the whole thing squared comes up to the same equation. But that's how you compute the variance. Now, what really we want is in applying the probabilistic time estimates is that when we get down to, I erased that we will actually need to compute the expected completion time of a path. Right? And you do that by adding the average completion time of the activities in the path. Alright, so for example, B, G, and I, on average, that can be completed. B, G, and I, so that would be 5.33 plus 11 plus 4. Okay, now again, just doing it by hand, but you don't have to do that because a template will compute that for you. What is important in the template is that you identify correctly all the paths. Okay, so let's see how the template works.
Which template are you opening?
This is the operations manager, this, I mean,
No, I mean this. one,
yeah,
just
let me
don't
go
have-
back, because that's not, this is for the forecasting.
This is on Moodle, it's in the course
Yeah.
essential.
Yeah, so here's the template, right? And this is what we will be using. Project management for CPM templates. And of course, we're dealing with probabilistic time estimates. Let's select that. And I think are these the numbers that were on that slide? They're not. I wonder if I can copy them. Of course, it'll mess up the formatting, but who cares?
If you pull it into, you might be able to keep this important.
Okay, so as I said earlier, you will not have to compute the mean and the variance because that's computed for you by the template. And if you look at the formulas, I don't, yeah. So here's the basic equation there. D7 plus 4 times E17 plus F17. They're basically just adding, using these numbers to compute the average. The variance, same thing, you have the difference between the pessimistic and optimistic divided by 6 squared, that's the variance. And the template will compute the average duration time of the critical path. Well, not quite yet, because these numbers here will be computed based on your input down here. Okay, so it says type in the yellow cells below the activities in the critical path. So what's path 1? Can you please identify? We have 3 paths, right? What are they?
A C
A, C,
E H I
okay? So that's one path.
and
Oops, I. And then path 2,
A D F H I
okay, and then path 3.
B G I.
Oh, actually, I didn't have to try type these 3 because if you start typing a letter there. Yeah, because I removed the formulas there, so it's not working. But you don't have to type in the path numbers. They are automatically entered by the template. Okay, so these are the 3 unique paths from beginning to end. And then here, you type in the critical path activities. What's the critical path we identified earlier? Remember what the critical path was? If you added this the longest average. I think the template also determines that. There you go. Highlighted in green. Okay, 54. If you added the completion times of the activities in column 1, that would be 54. All right. Path 2, the average completion time is 41.3 and 34.3. So here, 54 is the largest, so we'll list that here. A, C, E, H, I. All right. That's the completion time of that path, and then its variance as 41. So these are just computing numbers that will be used up here. All right, 54 is already identified as a critical path. Then a variance 41, a standard deviation of 6.4. How did we compute 6.4? It's just the square of 41. The reason why we have to compute variance first before we compute the standard deviation, is that variance, it can be added. It makes sense to add variances, but you cannot add standard deviations. So you have to go through the variance before you can compute the standard deviation of the path. So this gives you, a normal distribution, a curve of activity, the critical path. All right, its average is 54. So if you were the project manager, this tells you that if you target, if you say, hey, I will complete the project in 54 days. What's the likelihood of completing the project in 54 days? By your understanding of the normal distribution. Remember, 54 is the average. And in the standard normal distribution, the average is equal to the median, right? Which translates into what percent?
2%.
50%. So if you say, I'm going to finish the project in 54 days, the probability that you will complete the project is only 50%. Yes.
Now, there's a philosophical question on whether or not you should tell your boss or the customer.
Promise a lot, promise a little.
Under deliver, right? So
Yeah.
maybe we should lean our model more in the 65% range.
I don't know, if you say 55%, that means that the probability that the project will not be completed in your target period is 45%. That's a lot, I mean, so what are the consequences or the costs tied to project delays?
Plus or minus depending.
If it's in the millions of dollars, then you probably would want to say, hey, I'll probably aim for, instead of 54, let's say 60 weeks. At 60 weeks, you have a 82% chance of completing the project on time. If the project delay, you penalize like $1 million per day. That's a lot, right?
So we just have to hope that all of these kinds of measurables are defined in our contracts, right?
Yeah, that's why. Yeah. So when you write contracts, you better know your likelihood of completing a project. Okay, and this is one way of estimating that.
Yeah.
Okay. Was that Holden?
Yes.
Okay. So this is a way of quantifying project completion times in terms of probability of completing the project. Okay. We good? Are there more problems there? Oh, okay, so this is just what we identified earlier.
Yeah. You wanna do it in a short break?
Going to do this quickly? If you can develop a network diagram? Can do this in 5 minutes. And as I said, if you were creating a network diagram, you can simply just copy that and then paste it here, wherever. So you don't have to recreate the arrows and the nodes. Alright? And if you were asked to create an early finish, late finish information, just copy this and then paste it somewhere and edit.
What was that example on slide 21?
Slide 21. Yeah.
Mhm.
Actually, you can see the answer at the bottom.
This is self.
And
Well, that.
Practice it.
But it will be a good practice to don't look at the answer, just work it out yourself and see if you come up with the same
So
network diagram. Brian,
the irony that I was thinking of all this actually completely applies to this in every sense of the word. That's not how you write it, just saying.
oh, okay, I don't know how to play that game, so I can't really.
From start to finish, just define a specific point value, you have to get up to 100 elements, so you're strategically planning to get to this point.
Mm-hmm.
before your own end. And all of your strategic planning is based off of cards.
So how can you relate the Slack and
Productivity, what's left over, counting fits up to specific amounts. And you have to calculate these things pretty effectively to get to this point
Uh-huh.
going forward. And it counts the same way.
does it? Okay.
Yeah.
Be able to get the network diagram? Okay. So is this what you have? Good. And if you want to learn how to create, or at least to kind of do the forward pass and backward pass again, you can just run the, the slide present. So you can see the progression of the computation. And maybe for the assignment, you can just copy these, the squares and the, maybe not the nodes, I don't think they are. Oh, no, yeah, those are images. Okay, well, that was the last slide. I told you, it was a short session. Questions?